So the only difference between these two equations is their denominators. It means the only difference between their graphs is that the position. So if, for example, in this original function, x cannot be 0, and that is our intercept. It's our asymptote, vertical asymptote at x equals 0. For the new function, when we solve the denominator becomes 0, then we have the value for the new vertical asymptote, which is now shifted. Let's say it's shifted to the left. If it's a negative value, if it's a positive value, the new asymptote will be on this side. So the only difference is that the original function was shifted. So in this case, for example, to the left, and that's it. Okay. So to quickly sketch this hyperbola, just remember the horizontal asymptote is still the same. So let's look at our horizontal asymptote. If you shift it left or right, it's still the same, so it remains the same. The vertical asymptote is shifted. Where do we find it? By solving denominator, make the denominator of this one become 0. And because the coordinates are shifted, then we don't need to point out these two special values to indicate our scale. We can do that easier by find the y-intercept, because the hyperbola got shifted, it will cut the y-axis at some point, and if we can find the y-intercept, then we can indicate the scale for the y-axis already. Okay, so let's go to some example. Remember those steps. Horizontal asymptote remain the same, vertical asymptote is shifted, and solve it by and how do we find it? By solving this denominator becomes 0. And then we will find the y-intercept. Okay, so example, sketch this function. So firstly, horizontal asymptote remain the same, so indicate clearly by broken line. Now work out our new vertical asymptote by solving this equation. X plus 2 is 0. It means x cannot be, x is negative 2, and that is where our new asymptote is. So indicate the number carefully, nicely, so we have the scale for our x-axis, and that's where our vertical asymptote. Similar with sketching the graph of y equal k over x. If k is positive, the graph will be over here and here. Okay, and now if we can indicate the scale, the y-intercept here is mean we indicating the scale for the y-axis, which is all good. Okay, so if x is 0, then this will be a half. If this is a half, this is 1, and this is 2. And we did indicate our scale for the y-axis already. We can just point it out here that this is a half. Okay, now let's complete it by indicating the scale on both sides, and we're done. Okay, let's go to example 2. Example 2, where k is negative, and you have a number in the coefficient for x over here. But it's nothing complicated. We will still do the same. So horizontal asymptote remain the same. To work out vertical asymptotes, solve this equation. So if 3x take away 2 equals 0, x will be 2/3, and that will be our new vertical asymptote. So let's make 1 here, 2 here, so we have some gap to identify 2/3. So 2/3 is around here. That's our vertical asymptote. Now k is negative, so the hyperbola will be on this quadrant and this quadrant. Again, let's try to find our y-intercept. If x is 0, that would be 1. That's nice. And we have our scale for the y-axis as well. And we're done. Okay. So let's do one more example with b value given. So here, So we have b value, which is 2. Right. So example 3. So firstly, horizontal asymptote remain the same. To work out vertical asymptote, solve this. So 2x plus 3 equals 0. X is negative 3 over 2, which is 1.5. Okay. So this is negative 1, negative 2. So our vertical asymptote will be here. K is negative. So we know that the graph should be on this quadrant and this quadrant. Now let's find y-intercept to indicate our scale for the y-axis. So when x is 0, that's 0. That will be negative 1. So negative 1, negative 2, 1, 2, and we're done. So keep in mind again, horizontal asymptote remain the same. Work out the vertical asymptote. Based on the k value, we work out the quadrant and find the y-intercept and indicate your scale clearly on both axes, and we're done.